This is part 5 of the Module 5 lecture. In this section, we're going to talk about this example that we are going to solve with the help of Excel. So we're going to use Excel to create the binomial probability distribution, and we're going to use those probabilities that we will generate using Excel to answer these questions. All right, in this problem, we have a manufacturing company that regularly conducts quality checks on the LED light bulbs that they manufacture. So in here, the failure rate of these bulbs, or the probability that a light bulb fails, is 5% or 0.05. In this case, a random sample of 10 light bulbs is selected, and they want us to find the probability that zero bulbs are defective in this sample of 10, or exactly one bulb is defective, or 2 or fewer bulbs are defective. And the last part is asking us the probability of 3 or more bulbs are defective. All right, to do this, you could use the tables that the book provides in Appendix B for the binomial probabilities. Now, I don't know how easy it is to access the tables now in this digital format. And I don't know how easy it is to provide those tables during an exam. So to take advantage of not knowing that, I figured that I will show you how to create this probability distribution in Excel, so you get more familiar with Excel. And during the exams, what I will do is I will provide that little table that contains the binomial probability distribution for whatever problem we're solving. And then the expectation is that you can look at those probabilities and use them to solve or to answer the questions of the problem. All right, so in Excel, we use this formula equals binom.dist, and then in order you enter the value of the successes that you're interested in calculating the probability for, then the number of trials, then you enter the probability of success, and you can enter either the word false or true. If you enter the word false, that tells Excel that you're going to compute exact probabilities. That is the probability that the random variable is equal to whatever x value you enter in the formula. If you enter the word true, and remember they have to be in capital letters, then that tells Excel that what you want is what is called the cumulative probability. That is the value that the random variable is less than or equal to the value that you specify in the formula. I'll ask you that to please look at this video. It's called Module 5 Binomial Probability Distribution. It's in the Module 5 documents. It's relatively short, and it shows you how to construct the probability distribution. All right, if you follow that video, you will see how this is constructed. And what it is you open a brand new worksheet on Excel, and then in the first cell, you put the x, which is the values, the possible values of the random variable, and then you enter 0 through 10. Then in the next column, you label it the probability that the random variable is equal to any of these values. And then you enter this formula right here. And of course, when you enter that formula, you're going to put this x of 0 into that formula. There are n trials, so instead of n, you will write 10 or type 10. And the probability of success in this example, pi, will be replaced by 0.05. And we'll use the word false because we're calculating the exact probabilities. So here's the probability distribution for this example. So every probability is right here. And in addition, using Excel, you can construct this probability, the graph of the probability of this probability distribution. And you can see this is right skewed, and that is because the probability of success is 0.05. That means most of the successes, or the higher probability is going to be for the small number of successes, 0, 1, or 2. All right, so now that we have this, and I trust that you will look at that video to see how this is done, we're going to use this to calculate the probabilities that we're asked for in this problem. So the in part A is asking us the probability of finding 0 defective light bulbs in the sample of 10 light bulbs. So all you have to do is look at this table, look for 0 right here, and the probability that we obtain 0 bulbs in this sample of 10 is 0.598737. So here's the probability, and as I've been insisting, you write the interpretation of that number. So the probability that 0 bulbs are defective in a random sample of 10 bulbs is 0.5987 or 59.87%. All right, the next question is asking us the probability of finding exactly 1 defective light bulb in this sample of 10 light bulbs. Well, again, this is the random variable is exactly equal to 1, so all you have to do, go to this table, see where x equals to 1 is, which is right here, and here's the probability that the random variable is equal to 1. And so the probability that we will find 1 light bulb defective in this sample of 10 is 0.3151, which is right here in the table. Then write the interpretation of this value. Then the probability of exactly selecting 1 defective LED light bulb from the sample of 10 is 0.3151 or 31.5%. All right, so this is 2 cases of exact probabilities. Now let's look at part C. In here, they're asking us to find the probability that 2 or fewer bulbs are defective. So in this case, the condition is the probability the random variable is 2 or less. That is the probability that you could get a 0 or that you could get select 1 defective bulb, 0 defective light bulbs, 1 defective light bulbs, or 2 defective light bulbs. Because these are mutually exclusive, then we apply the addition rule that we learned in chapter 4, and we just add the probabilities. Now, the probability that 0 light bulbs are selected is right here, 5.98. The probability that we select 1 defective light bulb is 0.315, and the probability that we select 2 defective light bulbs is 0.0746. So the numbers are given in the table. You just need to select the right numbers. You add them, and you find this 0.9884. So then we interpret this result as the probability of finding 2 or fewer defective LED light bulbs in this sample of 10 light bulbs is 0.984 or 98.84%. Now, the next question they're asking us the probability of finding 3 or more defective light bulbs in the sample of 10. So in here, a smart idea to save calculations, and since we already calculated this quantity up here, is to use the complement. And so to look at the complement, x equal to 3 or larger, so it includes all the outcomes from 3 to 10. So that you will need to add all these probabilities. Well, an easier calculation is to use the complement and use the probability of getting 2, 1, and 0. And so that's what I did here. So the probability that the random variable is equal to 3 or a larger number is just 1 minus the probability of getting a smaller number than 3, which is the addition of the probability of the random variable being equal to 0 or equal to 1 or equal to 2. So we already have this number right here. So what you do is you do 1 minus that quantity, and that gives you 0.0116. So that means that the probability of finding 3 or more defective LED light bulbs in this sample of 10 is 0.0116 or 1.16%. All right, so here I'm showing you how to use, for example, the multiple probabilities in the table to get the probability, and here how you can use the complement to simplify your calculation and take advantage that a number that you already calculated. All right, so this example shows you how to use a table, and as I said, when the exam time comes, I will provide the table, and then I ask you questions like this, and then you will all have to just go to this table and find the required probabilities. So you don't need to use the binomial formula to calculate probabilities. All right, so as this example shows, it's very important that in order to understand how to use the complement to calculate probabilities, you need to visualize what are the outcomes of the random variable. And remember, the possible values of a binomial random variable go from 0 to the number of trials, n. Like in the previous case, it went from 0 to 10. So keep that in mind so that when you apply the complement of an event, you do the correct calculation. Please, this is very important to remember. Another important aspect of the binomial probability distribution is that depending on the value of the probability of success will determine whether the skewness of the histogram or the bar graph, depending on which tool you use, to represent the binomial probability distribution. So if the probability of success is less than 0.5, you will see a right or positively skewed distribution. If it is exactly 0.5, you will see a symmetric binomial probability distribution. And if it is more than 0.5, you will see a left or negatively skewed probability distribution, because the bigger numbers in the numbers of the random variable are more likely to occur. All right. Another important characteristic of the binomial distribution is the mean, how to calculate its mean and standard deviation. So the mean of a binomial random variable is just the number of trials times the probability of success. And to find the standard deviation, well, is use the square root of the product of the number of trials times the probability of success times the probability of failure. That's what this is telling you. Here's a brief example to show you this. So a total of 136 beverages are sold daily at some vending machine. Of these, 80.5% are soft drinks and 19.5% are bottled water. All right, assume that the purchase of drinks are independent, and it says compute the expected number of bottles of water sold and compute the standard deviation of bottles of water sold. So we have in here, the number of trials is 136, and since we're looking at the bottles of water that are sold, and so the probability of success will be 0.195. So using these two numbers, then we calculate the expected number of bottles of water sold, and that is 136 times 0.195. So it's expected that, or the average number of water bottles sold will be between 26 and 27, or specifically 26.52. To compute the standard deviation, as we mentioned, we compute that number of bottles that we're looking at, the probability of success times the probability of failure. So 1 minus this number. So if you carry out that calculation and take the square root of that product, then you get 4.6025 water bottles. All right, again, this is just a simple example to show you how to compute the mean and the standard deviation of a binomial random variable. All right, I will stop here with this. We're finished with reviewing the binomial probability distribution. In the next recording segment, we'll talk about the hypergeometric probability distribution.